Welcome to the Baboom Baboom podcast, your go-to source for expert tips on car stereo installation, vehicle wiring, and all things wiring related. Whether you're a seasoned pro or just getting started, we've got the advice to help you power up your ride. Get ready to crank up the volume on your knowledge and make your next wiring project a success.
You know that feeling, right? You hit the brakes, towing a heavy trailer, and it feels like your truck's doing all the heavy lifting. It's unsettling.
It's more than unsettling, it's a real safety hazard.
Yeah.
You absolutely need those trailer brakes working properly. Poor stopping, sway, it can lead to accidents.
Exactly. So maybe your trailer brakes feel a bit weak or just not right. What do you actually do?
That's what we're digging into today.
Yeah, today on the deep dive, we're tackling malfunctioning trailer brake systems. And, the good news seems to be you don't necessarily need to be a pro mechanic to figure some of this out.
That's right. A lot of the time, the fix is simpler than you might think. We're using an article today. It's called How to Troubleshoot a Malfunctioning Trailer Brake System, Baboom, Baboom.
Baboom, baboom, okay.
And our mission really is to give you a practical, step-by-step guide. How to spot common problems and hopefully fix them. We'll cover both the electrical side and the mechanical bits.
All right, so the brakes feel off. Where's ground zero? The Baboom article kicks things off with something pretty basic, it sounds like. The visual inspection.
Yeah, it sounds almost too simple, but honestly, you can catch so many issues just by taking a really good look.
Okay, so what are we looking for specifically?
Well, the article points out a few key spots. First up, the trailer wiring harness itself. Trace it along its whole length.
Right.
Look for obvious scuff cuts, scrapes, anywhere the insulation's rubbed off and you see bare wire. Corrosion's another big one.
That green or white crusty stuff.
Exactly, especially at connections. And don't just look, give the connections a gentle wiggle. See if anything feels loose.
Okay, makes sense. Kind of like checking any power cord, really. What about inside the tow vehicle? The brake controller wiring? The article mentions a blue wire and this CCA wire thing.
Right, so think of the controller as the command center sending the stop signal. That blue wire is the main pathway for that signal.
Gotcha.
The article points out it's often copper-clad aluminum CCA wire. You want to follow that blue wire, again looking for frayed insulation, maybe spots where it's pinched or crushed, broken connectors too.
So just making sure the path is clear and secure.
Pretty much.
Yeah.
Check those plug-in connectors carefully. Are they feeded properly? Any corrosion in there?
Seems like wiring is a big theme early on. Okay, moving to the trailer itself, down by the wheels. Brake magnets, drums, rotors. What's a visual check there?
So the magnets are key. They actually create the braking force from the electricity.
Right.
Inspect the wires going to them. Frayed, broken, bad connectors. Same drill. Then look at the drums or rotors, the big metal parts the brakes grab onto.
Okay.
A little surface rust might be okay, but look for really deep grooves or like a thick layer of rust or gunk that would stop the brakes from getting good grip.
And the article also flags the breakaway switch and its battery. Seems small, but why check that now?
Good point. It's easy to forget, but it's super important. That's your emergency brake if the trailer ever detaches.
Oh, right.
So you need to make sure the switch isn't busted, the pull cable's attached right, and this is crucial. The little battery that powers it in an emergency actually has power and works.
Wow. Okay. So just walking around and looking carefully can tell you a lot. The article mentions that electrical issues often boil down to bad wiring, and it talks about the benefit of CCA wire, again, corrosion resistance. Why is that so vital here?
Well, think about where trailers live. They're out in the rain, snow, road salt. It's rough on electrical stuff.
Yeah, true.
CCA wire, the copper-clad aluminum, kind of gives you the best of both worlds. The aluminum core is light and conductive, but the copper coating fights off corrosion really well. That helps keep the signal strong and avoids those annoying intermittent brake problems.
Okay, so visual inspection done. Let's say we didn't find anything super obvious. The article says the next step is testing the trailer brake controller. How do we do that?
Right, the command center. First, simple check. Turn on your truck. Does the controller power up too? Most have a light or a display that should come on.
Okay, power on, check.
Then, find the manual override. It's usually a lever or a button. Engage that. If you got a display, you should see some numbers pop up, showing how much braking force it's trying to send.
So it turns on, and it shows something when I manually trigger it. What about using the actual brake pedal?
Exactly. Step on your truck's brakes. The trailer brake lights should come on too. That's another quick visual confirmation.
Got it. Lights work.
For a deeper check, you'll need a multimeter. set it to DC volts. You can test the voltage output right at the trailer plug, specifically on the pin connected to that blue wire.
Okay, testing the blue wire voltage.
Yeah. And as you press the brake pedal down harder, that voltage reading should climb up. More pedal, more voltage.
That makes sense. Stronger signal for harder braking. What if it's not doing that or not powering on right?
Need top-quality electrical wire? Baboom's got you covered. Get your 6-pack today. Each combo comes in 6 different colors and a total of 600 feet of wire. Perfect for any project, and you won't find a better price in the industry. Head over to baboom.com now to snag yours. That's baboom.com.
The article suggests checking 2 main things. First, the controller's own ground wire. Is it making a good, clean connection to the vehicle's metal chassis? A bad ground here causes headaches.
Right. Grounds are always tricky.
And second, is it getting consistent power? Check its power wire connection. And, if the wiring to the controller looks old, frayed, corroded, maybe think about upgrading, potentially with that CCA wire for reliability.
All right, controller seems okay. Next stop, according to Baboom, the brake magnets themselves. Down at the wheels again, right. How do we check those out?
Yep, back to the wheels. This gets a bit more hands-on. You need to safely jack up the trailer and support it on stands. Then take the wheels off.
Okay, wheels off.
Now you can see the magnets clearly. Look for physical wear or parts of the magnet face worn down thin or damaged. And like before, check the wires connected to the magnets loose, frayed, broken.
And then we break out the multimeter again for resistance.
Exactly. Switch your multimeter to the ohm setting. You're going to measure the resistance across the 2 wire leads for each magnet individually.
Okay, what are we looking for?
The article gives a pretty specific target, between 3.0 and 3.8 ohms per magnet.
3.0 to 3.8 ohms. What if it's outside that range?
Well, if it's way lower, like close to 0, that probably means there's a short circuit inside the magnet. If it's way higher, or you get no reading at all, what they call an open circuit, there's likely a break in the wire coil inside.
So either way, it's faulty.
Pretty much. It won't create the right magnetic field to pull the brake arm. The article also suggests a neat practical test.
Oh, yeah.
With the wheel still off, if you carefully apply power directly to the magnet's wires, maybe using your tow vehicle's battery through the plug, and then try to spin the brake drum by hand, you should feel it grab. A noticeable drag or resistance as the magnet energizes and tries to stop the drum from turning.
Ah, okay, so you can actually feel if it's working, and if a magnet's bad, replace it.
Yeah.
And check that wiring again, maybe upgrade to CCA.
Yep, it's a recurring theme. Those connections down by the wheels take a beating, so good wiring like CCA really helps ensure they keep working reliably.
Okay, controller checks out, magnets seem okay, or we replace the bad ones. Still having issues. The article moves on to grounding and electrical continuity. Sounds important, but maybe easy to overlook.
Absolutely critical. You can have the best controller and magnets in the world, but if the electricity can't complete its circuit back to the source through a good ground, nothing works right.
Right, the electricity needs a return path.
Exactly. Bad grounds cause all sorts of weirdness. Weak brakes, intermittent brakes, sometimes no brakes at all.
So how do we troubleshoot grounds?
Start visually again. Check every ground point, the main one on the vehicle frame where the trailer harness connects, and any ground points on the trailer frame itself.
Looking for
Corrosion again, loose connections, make sure they're bolted tight to clean, bare metal. Then grab the multimeter, set it to continuity or the lowest ohm setting.
Okay.
Test the connection between the vehicle ground point and the trailer frame ground. You want to see basically 0 ohms resistance. That means you have a solid, unbroken ground path.
And if the reading is high or jumps around?
That signals a problem. Time to clean things up. Use a wire brush, sandpaper, whatever it takes to get those connection points shiny and clean for good metal-to-metal contact.
That makes sense.
And if any ground wires themselves look corroded or damaged, replace them. And again, the article mentions using quality CCA wire for grounds too can really help, especially in preventing corrosion issues down the road.
It really does sound like bad grounds are a common culprit.
Okay, we've covered a lot of electrical checks. The last phase in the article shifts gears a bit to the mechanical side. Brake adjustment and operation.
That's right. Because even if the electricity is doing its job perfectly, telling the brakes to engage, if the mechanical parts aren't set up right, they won't actually stop the trailer effectively.
Like the brake shoes not hitting the drum properly.
Exactly. The article focuses mainly on drum brakes here. If the shoes are worn way down or just adjusted too far away from the drum, they won't make good contact when the magnet pulls the lever.
So how do we check and adjust that?
First step, Again, usually involves removing the brake drum so you can see the shoes inside. Okay, drum off.
Look at the thickness of the brake lining material on the shoes. Is it worn really thin, almost down to the metal shoe itself? If so, they need replacing.
Got it. If they look okay, then we adjust.
Then you adjust. Usually there's a little star wheel adjuster you can reach through a slot in the brake's backing plate. You'll need a brake spoon or a flathead screwdriver.
Right.
You turn that star wheel to push the shoes outwards, closer to the drum. The goal is to expand them just enough so that when you put the drum back on, the shoes lightly drag against the inside surface.
Lightly drag. How do you know it's right?
Once the drum is back on, spin the wheel by hand. You should feel a slight consistent resistance, a light dragging sound.
Yeah.
If it spins totally freely with no drag, they're too loose. If it's really hard to turn, they're too tight and will overheat. You want just that slight drag.
And the article suggests listening, too.
Yeah, a final check. Apply the brakes using the manual override on your controller. You should be able to hear a distinct click or hum as the magnets engage, and maybe a slight thud as the shoes make contact inside the drum.
The article really emphasizes that adjusting brakes regularly is key, especially for systems that don't self-adjust. Sounds like basic maintenance that pays off.
Oh, definitely. Proper adjustment means safer stops, and it helps the brakes wear evenly, making them last longer. It's crucial for safety and efficiency.
Okay, so let's quickly run through that troubleshooting path again. Start with a good look, the visual inspection.
Yep, check all the wiring, connections, components for obvious damage or corrosion.
Then test the brain, the brake controller. Make sure it powers up, responds, sends voltage.
Check its power and ground, too.
After that, investigate the magnets at the wheels. Visual check, resistance test, maybe that physical drag test.
Looking for that 3.0 to 3.8 ohm range? Check the wiring there, too.
Then double-check the foundation grounding and continuity. Clean connections, solid path.
Absolutely critical. Use that multimeter.
And finally, get mechanical. Inspect the brake shoes and adjust them correctly for that slight drag.
Especially important for non-self-adjusting drum brakes.
That seems like a really solid, methodical approach. By going through those steps, you should be able to pinpoint most common trailer brake problems.
Exactly. It breaks down a potentially daunting system into manageable checks.
And like that Baboom article keeps reminding us, having reliable trailer brakes isn't just convenient. It's about safety for you, your passengers, your load, everyone on the road. Gives you real peace of mind.
For sure. And if you want more details, the original article on the Baboom blog apparently has more tips, especially on using CCA wire effectively and other trailer safety points. Worth a look.
Definitely. You know, thinking about how all these electrical and mechanical parts have to work together perfectly on trailer brakes, it makes you wonder, doesn't it?
Wonder what?
What other seemingly simple maintenance checks, maybe on your truck or trailer, could have a really big impact on safety that maybe we don't think about often enough? Something to mull over before the next haul, perhaps.
Need top-quality electrical wire? Baboom's got you covered. Get your 6-pack today. Each combo comes in 6 different colors and a total of 600 feet of wire. Perfect for any project, and you won't find a better price in the industry. Head over to baboom.com now to snag yours. That's baboom.com.